In this last lecture in this series about spatial data infrastructures, we're going to discuss the value chain of data, business models, and data policy. After this lecture, you are able to describe the value chain of data and explain the cost and strategic risks of selling data, and explain why a data policy should be always linked to a business model. Many products and services that we use are part of a value chain, also data. But let's first look at a simple example: beef. Before the beef arrives on our plate, it has gone through a whole value chain. First there's the farmer that has to feed the cow. And when the cow is old enough to go to a slaughterhouse, it's sold for a certain price per kilo that's much less than the beef on our plate. The butcher who slaughters the cow sells it to customers or to a factory where it gets packaged. After packaging, supermarkets can sell it. The price per kilo has increased. But if the meat is bought by a restaurant, the price per kilo also depends on the quality of the restaurant. A chef of a Michelin star restaurant can charge much more than a fast food restaurant. So you can see that the price of beef increased throughout. The added value is the cow being slaughtered, the beef being processed and packaged, and the services that come in a restaurant with serving the beef. Now let's have a look at data. So raw data has the lowest value when it's collected in the field or gathered with sensors. But if the data is validated, then it increases in value, and we slowly turn it into information when we aggregate it with other data, combine it with GIS analysis, combine it with other kind of data analysis. We add knowledge to the data. And at some point, the data turns into useful services and products that we offer to governments, to private sector, or to society. And then even these services can be aggregated. So in each step here we add value and the price of the data increases. So raw data has a very low price and aggregated services have the highest price. Let's illustrate this with an example. Our meteorological service collects rainfall data. This raw rainfall data are point measurements at meteorological stations. However, if we validate the data and we aggregate the data to the national level by interpolation, the value is added. If we combine this data with traffic conditions, for example, then more value is added, and we can provide this as services on a mobile phone to display trends in rainfall, where it and when it occurs, but also how it affects our daily life. So in this way, the raw data in the end of the value chain can have a very high value that also people are willing to pay for. A lot of raw data is collected by public bodies, and once this is available as open data, private sector research or other public sector organizations can add value to this data and can even sell this to the end user. And this brings value for the economy, because for products and services there's also VAT, and it gives employment. So if the basis is open data and innovation is taking place and people can add value, then this is good for the economy. And lots of studies show that that is a way of improving the modern economies. Or in other words, data is the new oil. There are still many people, organizations, and governments that want to sell raw data. They overestimate the return on investment of selling the data, and they underestimate the cost of selling data. There's a legal cost of creating and enforcing restrictive licenses. In addition, there are costs for technology to restrict access and use of data. When you sell data, you also need to keep an administration of the issued licenses. And when you sell data, you also want to promote the data, and that has marketing costs. There are also strategic risks of selling data. There's a low willingness to pay for digital products. Many people can easily make copies, and probably you yourself sometimes copied music or movies. It's only recently that through streaming services like Netflix or Spotify, you can have access to these services. Data products, however, are easily copied and shared with others without you knowing that that happens. Another risk is that competitors or communities also have that data but provide it as open data, while you are still selling it. A nice example is OpenStreetMap. OpenStreetMap is crowdsourced data and it provides a very complete map of the world, and you can use the points, lines and polygons for free for your own purposes. When I found out in a certain country when I established an SDI was that the mapping agency was still selling road data for money. So I uploaded the whole OpenStreetMap dataset for that country, so the road data was there for free. My point to that organization was it's okay to sell data, but then you need to take into account the value chain and you need to add value. For example, if the data would include road conditions, or where traffic lights are, or speed, or navigation. Having road data included in a navigation system that is used in cars is probably one of the highest added value that you can achieve with the data. But selling road data doesn't give a lot of clients because that's already available for free. Let's have a closer look at OpenStreetMap. Probably many of you know Google Maps. But here, as you can see in the area in this example, Olorkesi in Narok County in Kenya, we see that Google Maps has no data at all, while on OpenStreetMap there is a lot of data. This data was created during a mapathon at IHE Delft, where our students mapped this whole area, which was suffering from a drought. And until today, there is still no data in Google Maps. Now let's compare the two data providers. OpenStreetMap has a copyright at the community, so the copyright remains at the users who produce the map, while Google has a corporate copyright. OpenStreetMap does not collect privacy-sensitive data, while Google collects privacy-sensitive data for advertisements. That's part of their business model. With OpenStreetMap we have access to vectors, points, lines and polygons that can be used in GIS, while with Google Maps we only get a picture that we can use as a backdrop for navigation. With OpenStreetMap you are free to use it in other products and services and add value. With Google Maps this is not possible. OpenStreetMap is often more detailed in rural areas where there's a need for humanitarian work, research, or where NGOs are active. Google Maps, however, is more detailed in urban areas because there is the main market where the points of interest such as restaurants and hotels and shops can be indicated on the map. And because they collected privacy-sensitive data, they can advertise these places to you through different resources of Google that you use. Here's an example of how complete OpenStreetMap data can be. Even tunnels and traffic lights are included on this map of Delft around IHE Delft Institute for Water Education. For mapping in OpenStreetMap we can organize mapathons. Before we start organizing a mapathon, we can use MapSwipe. It is a mobile app where we can indicate areas where there are settlements, because those are the important ones to map for humanitarian aid and for disaster management. The data collected with MapSwipe is then converted to a settlement layer which is used in the humanitarian OpenStreetMap team task manager, which cuts the area into different tasks that users can use to map in a mapping project for a mapathon. During a mapathon, a group of people can easily map areas that are in need of data. And that data will be immediately available on OpenStreetMap for further use. You can also digitize in OpenStreetMap without mapathons. In this demonstration you can see how we can use data from OpenStreetMap in GIS. This is QGIS, and I can search for places using the geolocation plugin. So we go to Olorkesi, which was the example from the mapathon, and look at the data that is available. And I'm interested in the rivers, so I want to download those rivers from OpenStreetMap as real vectors that I can use in my study. So there's a plugin which is called QuickOSM, and after installing the plugin we can load it, and we can look for keys and values, which is the way OpenStreetMap organizes the data. And I use key waterway and value river, and I want all the data in the map canvas. It generates this little script which is sent to the server, and then it will download the river. And let me style it a little bit. There it is, and then if I hide the background picture, then I see here the downloaded river. You see more streams on the map, but they are tagged differently. Here we used waterway river, but there's also waterway stream, waterway canals, etc. So everything that you can see on this background OpenStreetMap can also be downloaded as real vectors for your study. And if something is missing, you can simply add it by digitizing. So if things are already freely available, it doesn't make any sense to sell that data, unless you add value. So how to decide on this? Therefore you need a data policy. If you start making a data policy, you need to have a commitment of all the contributing stakeholders, because the roles and responsibilities will be defined, but also if data needs to be open or if it has added value and you can sell it. Therefore it's very important that the data policy is linked to a business model. At the government level there will also be data policies. They can be very restrictive or they can be very open. In Europe we have the INSPIRE directive that determines that government data needs to be open as much as possible and disseminated through SDIs. Another example here is from Rwanda. There are also countries that are very restrictive. For example, in a project I worked in a country where the data policy says that everything that is measured in the water is property from the water authority. And the same law says that the water authority has the mandate to sell data. This is of course not in line with what we discussed earlier, that government data needs to be shared as much as possible because the taxpayer has already paid for it. And in many cases, projects from other countries have supported the collection of data and even whole SDI. So if the law doesn't allow that the data becomes available, we have a hard time solving environmental problems because each time a project needs to collect again the data and then it gets lost into governments and authorities. So I hope this lecture series about spatial data infrastructures was useful, and that data sharing is important if we want to do environmental management.